Hello guys, this is another video, and yeah, it's been a long since my last video as usual also. But okay, in this video we are going to solve a problem 19 of a statal math Olympiad of Mexico, and I hope you all guys enjoy this video. And I'm sorry for my pronunciation. Again, I'm not a native speaker, but I do my best. And the problem asked to us for how many numbers of 3 digits are, where exactly those numbers have one digit equal to 5. Okay, and yeah, this problem it's quite easy, but if we don't solve this properly, we can get a lot of troubles or problems during solving it. Okay, and yeah, this problem is a such kind of problem which is too easy if you know properly how to solve it, but if you don't get the idea, probably you spend a few time doing it. Okay, let's crack this problem. Okay, in general this problem asks us for numbers of 3 digits. Okay, let me write digit 1, digit 2, and digit 3. Okay, we are searching for numbers where appears exactly one digit equals to 5. For example, oh my god, okay, let me switch the color. Okay, for example, this number, it's a valid number because it's a number with 3 digits and with exactly one digit equal to 5. So this is a valid number. Okay, and this number is invalid. Okay, because we don't have exactly one digit equal to 1. Okay, and to find all those numbers, essentially it's natural to think that we have essentially 3 cases. In the first case, it's when the first 5 appears in the first position. Okay, the other case is what happened if this 5 appears but in the second position. And the third case, it's when a 5 appears in the third position. Okay, and yeah, let's crack this problem into 3 cases. Okay, this is case 1. Case 1, it's when we have a number with 5 in the first position, but B and C, and those digits can be chosen arbitrarily. Okay, in the first case we need to look for how many numbers are of this form. Okay, and it's quite easy because since b is a digit, b can be a number between 0, 1, 2, 3, 4, 5, 6 up to 9. And in the same way, c can be a number between 0, 1, 2, 3, 4, 5, 6, so on up to 9. But we cannot choose B or C equal to 5, because it might lead to a invalid number. So we need to choose another one, okay? And 0 is also a possible value, since if both b and c are equal to 0, we get 5,000, which is also a valid number because it just have one digit equal to 5. So in this case, uh, b and c can be all the digits except by 5, okay? So to choose b, we can choose b and c of how many ways? This is like 10 ways, 9 ways each, okay? And hence, there are exactly 9 times 9, which is 81 numbers of this form. And yeah, the case 1 is solved. Now let's pass to the second case, case 2. In this case we have also the same 3 numbers, but now what happens if now the number is of this form with a 5 in the second position? In this case, again, b can be a number between 0, 1, 2, 3, 4, 5 up to 9, and c 0, 1, 2, 3, 4, 5, 6 up to 9. But again, we only are allowed to have one number, exactly one digit equal to 5, so we cannot choose 5 again to b and c. But what if the number is like a 0, for example? In this case, if the number is 0, we get a b equal to 0 implies numbers of the form 0, 5, and let's put just another one like 0. And this is a invalid number because we are counting number of 3 digits exactly, okay? So b cannot be 0. But let now explore what happens if b is not 0, the 5 and c. C definitely can be equals to 0 in this case, because if b is not equals to 0, then we have, for example, a number like 7, 5, and another value can be 0. It's also a valid number of 3 digits. So in this case, we cannot remove the 0 option. It's okay. And let's count the possibilities for b and c. B have 10 options in total minus 2, which is 10, 9, and 8 possibilities. And we have for C exactly 9 possibilities. So we can choose, we can found, and we can find 8 times 9 numbers of this form. Okay, now let's move on to the case 3. So in the case 3 we have that basically, and the 5 is in the last position and b and c are arbitrarily, and okay, as above, b cannot be 0 because it could lead to any invalid number. So b have other 8 possibilities, and of course c can be also 0. So again, as above C can be chosen of 9 ways, and hence in the third case we have also 72 possible forms of these numbers. So in total, by case 1, case 2, and case 3, we have the total numbers with exactly 1 digit equal 5 are 72, and the first one 81, or yeah, and this is 2, 4, 5. This is 7 times 3, 22, and the number is 2025, which is the B option. And yeah, that's the correct way of solve this problem. It could be challenging in some way, but I think that the natural instinct that we have when we read this problem, it's automatically choose the problem and divide this problem into cases and solve each case by separately and add up all the results obtained.